Okay, so to wrap up the transformations part of Unit 3, this is going to be video 46 and 47 because I really was thinking about it and there's no reason to do another video, especially with your transformations of functions cheat sheet kind of thing there. It's all good. So we'll talk about stretch and shrink all together, vertically and horizontally. Okay, so there are two types of stretch and shrink, vertical and horizontal. I just mentioned that. When I say stretch or shrink, I want you to think of the old school dilation. So when you talked about transformations last year, you did translations, reflections, rotations, and dilations. This mostly aligns with dilation, so something gets bigger or smaller. But instead of it being an object, meaning a triangle or a rectangle or something like that, we're talking about a function. Now, that's going to be a little bit weird because, well, how does a function get bigger? Well, it doesn't. It just stretches or shrinks. But you'll see what I mean in a second. So let's go with vertical first. Basically, when you do a vertical stretch or shrink, okay, you are multiplying some variable or some number, a, we'll call it, times the entire function. Okay, so you're going to take that number or that scale factor and multiply it by times the function. Typically, this would go in front of x. So like x would be 2x or 3x or something like that, or 1/2 x. Now, just like a dilation, if the scale factor or a is greater than 1, it's going to get bigger. But in this case, we're talking about stretching. So, for instance, I'm not going to use Desmos so much because we're going to use this a whole lot. But say I had the function f of x equals x squared. Okay? Now, let's say that I wanted to multiply this function by 2. It's going to stretch 2 times. So, for instance, I'm vertically stretching it. So pretend like I'm trying to grab it at both ends here, and it's going to go up. So vertical stretches means it's going to go up like this. Now, it means that it's going to get thinner or skinnier. Okay, so think of it like that. When I say vertical and horizontal, I want you to really kind of think about using both hands and going like this. Because if I stretch this function out, it's going to get skinnier, but it's going to get longer. Okay? If the scale factor is less than 1, it's a shrink. So we're going to go back here, right? And I'm vertically shrinking it, so I'm kind of pushing down on both ends. That means the function is going to get wider, okay? And it's going to get shorter. Okay, so vertical, stretch, and shrink. Horizontally, we're taking the same principle, we're just doing something different to it. Now, I'm going to multiply this x value, or every time I see this x value, by a fraction. And the fraction is 1 over a. But a is what the actual scale factor would be. So, if a is greater than 1, it's a stretch. Now, horizontally, let's use the same function, x squared. Instead of going like this, like you're grabbing and pulling, you're going like this and pulling. So, if a is greater than 1, it's a stretch, which means, let's say this was 2, which is greater than 1. It's 1/2 x, which means it's going to get like this. I'm stretching it out. So it's going to get shorter but wider. Okay, horizontal stretch. Horizontal shrink, same principle, but a is less than 1. Now that's going to look weird here. You're saying, oh, well, how is it less than 1? Well, if this was 1 over 0.5, 0.5 is less than 1. So this is actually going to be 2, so it would get shrinked. It would get shrinked. I don't know. I'm a math teacher. So horizontal, grab it by both ends here, shrink. Okay, so it's going to get thinner and taller. So they pretty much have the same effect on each other. When we start using Desmos, this is going to be a lot easier to see. Vertical stretch, okay, vertical shrink, horizontal stretch, horizontal shrink. Okay, so think about grabbing the function on both ends and moving it how you need to. That's how I look at it. It'll be a lot easier for you. So, fear forms. I still am going to have 2 separate fear forms for you because that's how I made it. What transformation do these most align with? Well, I said it a couple of times. It's going to be dilation. Okay, so number 1 on 46. X squared is vertically stretched by a scale factor of 3. What do the pre-image and the after image or prime image look like? Well, it's going to look just like we said. Vertically stretched out, so it's going to look a little bit thinner. And then number 2, it's vertically shrunk by a scale factor of 1/2. So it's going to get a little bit fatter. It's going to get a little wider. Same principle on figure 47. Probably should turn the light on. It's really weird. Oh, okay. Same exact questions. It's just horizontal shrink and horizontal stretch. Okay. Work these out on Desmos. Actually physically put these into Desmos. You're going to see what these things do. And don't put one function in and then redo the function so you have like just one picture. Put one function in, so for instance, put x squared in, and then on the line below it, because you can do several different functions, make sure you put the dilation or the scale factor for all of these things, because then you'll see that it makes a completely big difference. Okay, all right. Hard to say. Hopefully this worked out. Hopefully, if it didn't, you understand a little piece of it, and we're going to go. So only 2 videos this week. Bye-bye.